Okay, I think we'll get going. So thank you all for joining today. I'm Abby Lindberg. I'm the Director of Applications Engineering here at GelSight. Today we're going to be talking about replica material and how we can use GelSight to replace replica material, or how we can use GelSight with replica material, making molds of parts in hard-to-reach locations. Just a couple items before we get started. We'll be recording this session and putting it on YouTube for anybody that might have missed it. And we'll also have the chat active throughout. So we have Waleed from the applications team answering questions live as we go. And just a side note that the Q&A might not be working, but the chat should be live. So feel free to ask your questions there. And with us today, we have Thierry Mantel. So I'll pass it over to him to introduce himself and get the webinar started.
Okay, thank you, Abby. And hello, everyone, and welcome to this new webinar. I'm Thierry Mantel. I'm the Vice President in charge of the GelSight distribution network and also some key accounts. So Replica today. Replica is a very interesting subject in the industry because everybody wants to get rid of it, but at the same time, it's often, the only way to have access to a defect in a remote location. Replica is typically used when, the area to measure is not reachable by classical metrology tools due to the complexity of the part, or simply because, the part cannot be moved to go to the metrology lab. So people take a replica locally and analyze it afterwards. The aerospace industry is a very large consumer of replica during their manufacturing and assembly processes, and also during, inspection phases of maintenance operation for engines, actuators, landing gears, any kind of parts which is submitted to corrosion, to shocks, to erosion. Molds are really something which is well, known and used in the industry. Molds are also used in the automotive industry, but more, during the upstream, phases during the industrialization of a product, but it's not, of course, used on a regular basis, on the production line. Discussing with our customers, in the domain of aircraft engines or landing gear manufacturers, and also MRO shop, it's not rare to hear that they are taking dozens, even hundreds of molds, per engine inspection, or just to qualify, the manufacturing process of a landing gear. This is really very, very significant. And when you see, the time needed to prepare and to apply the replica, considering the curing, the slicing of the region of interest, the measurement under a microscope, under a shadowgraph, this takes, in the best case, between 30 and 45 minutes. Sometimes it takes days, when the metrology lab is overloaded and, there is a queue to have access to the lab. And then you have, the administrative task, administrative protocol to ensure the traceability of the mold, traceability of the measurement. The mold needs to be well referenced according to your quality management, system procedures. So as you can understand, the use of replica is costly, fastidious, and has a significant impact in terms of cost and lead times for manufacturing and maintenance operations. And everything which can simplify or replace the replica process is really something which is good to take. And this is really exactly where GelSight products bring a breakthrough by suppressing, these replicas in most of the case, or by directly measuring these replica on the spot. And this is what pushed GelSight to develop Modulus, which is capable to reach remote locations in very complex environment like aircraft engines, and also capable to measure, defect inside a bore with our 90-degree probe. This is really something we brought on the market recently, and we see a tremendous success with it. And as you will see during the demonstration with Modulus, it takes just 1 or 2 minutes to characterize a defect, and from the scan to the writing report, it's really once again 1 or 2 minutes. And now I will let Abby demonstrate, the typical workflow using GelSight. Once again, from the scanning of the surface of the part to the writing of the report. Thank you, Abby.
Thanks, Thierry. So the first thing that I'll show is actually creating a replica. So we'll go through scanning a replica or a mold with GelSight, and we'll also scan a part directly. And I'm going to start with the replica because it'll need to cure as we go through some of the rest of this presentation. So what I have here that I'm using today is the Plastiform P80RA. See that there? We do like using this one specifically because it has it's a pretty hard cure. So the durometer it cures harder than some of the other replica materials that we've tried, and that's good for a contact system to measure. So the first thing that I'm doing is actually just installing the nozzle here, and it'll mix as I squeeze the handle. So I'm going to switch over to my other video here so you can see while I do this. All right, and on the tabletop here, I've got our piston with our wrist pin bore, and we like scanning this. We'll access this directly with the GelSight modulus here in a minute, but I have a defect right inside of here, and I'm going to go in and squeeze this and just apply my replica to that surface. So I'm just going to put it right in here. All right, and I'll take this out. And we found that when we're making molds or replicas, we have a little bit of air bubbles sometimes, and minimizing the air bubbles can be done a little bit with a piece of plastic or something pressing down onto the surface. That can help with our repeatability there. So I just press that onto the top, and we'll let this sit and cure while we talk a little bit about how GelSight works and a little more detail about GelSight with replica. So I'll switch my video back over here. And we'll talk about the GelSight system. I've got our modulus system here. And what we have is we have a camera and a lens and an illumination system. And when we click this button, we're taking a series of images. I'll actually take the gel out of the straight lens here to talk about that. So we'll take 6 images, one with each one of these banks of LEDs illuminated. And we use a process called photometric stereo to turn that into 3D data. And in conjunction with that, we have our gel sensor. And this is what lets us look at surfaces regardless of optical properties. So like glass, metal, textile will all look the same to us. But the most important part of this when we're measuring replica material is the hardness. So the gel's pretty soft here. And if you haven't felt one before, you can kind of think about it like your fingertip. It's pretty much the same durometer or hardness as your fingertip here. And that's what we'll consider going as we go through some of the results from our replica studies. We'll see that the hardness really matters because we do need to press the gel onto the surface. So we need the gel to deform before the mold deforms to measure it accurately. So I'll actually go ahead and share a couple slides here that share the results of some studies that Frank Chang on our applications team has done. Let me pull this back up here. All right, here's the next one. So this set of studies was using the same type of replica material that I'm using right now, the Plastiform P80RA. It's specifically used for roughness applications, but can also be used for defects. But I'll just kind of cover what the results are on the screen here. So on the first graph and with the first images here, we basically measured the surface of a Mitutoyo reference standard directly, and then we also measured a replica of that. And then we did a machine surface where we measured that surface directly and a replica of it. And then we also did direct scans on sandpaper and then on a replica of the sandpaper to kind of cover, various types of surfaces and how measuring them directly varies or compares to measuring them with replica. And what we can see here when we measure, we'll look at the first graph here. We can see we're measuring, when we measure this directly, this is with the MAC system, we get very consistent results. And the results are pretty good when we measure it with the replica material as well. I was pretty pleased with these results. There's a little bit more variability, but this is 3 different scans on the same replica. And you can see that across these different samples as well. And the sandpaper example being one of those rougher surfaces, we're looking at the roughness over an area on that as well. Now, we also have another set of data where we tried another type of replica material, and these are the Plastiform M60 and M70. And I'll hold one of these up. And this is also another type of commonly used putty that we see where it's two parts. You basically take equal parts of each compound here and you mix them together and just press them onto the surface and it'll cure it that way. So in this example, we took replicas of these certified groove specimens. So we use these pretty often for characterizing our systems. So these are certified groove depths ranging basically from 10 micron to 500 micron. And what we have on the top graph here is using plastiform M60 and the bottom one is M70. And when I'm saying these numbers, I'm actually referring to the durometers. So M60 would be the softest, M70 would be a little bit harder. And then when I'm mentioning the P80 RA, 80 is going to be harder than that. So we're basically going kind of in order of hardness here. And what we can see on the top graph for M60 is the results of the single study are in blue. And we've also plotted in orange just the accuracy spec of GelSight so that we have a little bit of a reference in here on how good these results are. So this is just one single study. So these blue dots here, you can see we're pretty close to our expected uncertainty, our expected range of accuracy in when we're using the GelSight system. So we're pretty pleased with these results. Coming in, measuring a mold instead of the part directly. Obviously, there's going to be a little bit more uncertainty because we're measuring the mold, but pretty close to our expected accuracy of measuring directly. And then we see on the bottom here for M70 even a little bit better, and it's a little bit harder cure, and the results are a little bit better. And I'll mention again that the blue represents just one study, whereas our accuracy specs encompass a lot of studies. So we'll see these single data points here. And on the next slide here, this will really show kind of the difference between the durometers. So I added one further data point on these. And on the left-hand side here for M60, we see when we get to a groove that's about 250 micron deep, we see the uncertainty increase significantly. Because when we're measuring a groove that's deeper, we have to press down harder onto the surface. So you'll see this basically indicates that the mold was deforming when we were at depths of around 250 micron. And then when we look at the M70, the harder cured replica, we see that when we get to about 500 micron, that's when we see that uncertainty skyrocket there, basically, because we're pressing down harder to get to the bottom of that 500 micron groove. So that's when, so you'll see that basically the threshold for when that change happens is different based on the durometer of the replica material. So there are plenty of times where we see some putties or replicas in the field where they might be too soft for the GelSight system. So that's just something to keep in mind if we're using replica with GelSight. And the last data set that I wanted to share on this topic is also comparing M60 and M70, and also shows this this durometer point here as well. And on the left-hand side here, we have two different replicas that were scanned 3 times with M60, and on the right-hand side, we have 2 different replicas that were scanned 3 times with M70. And we can see the results are still, they're still pretty good. We're within about 3 micron range here, but you do have a little bit more variation with the softer replica than you do with the harder one. So that's what we're kind of indicating here. So with that, I'll stop sharing these slides, and hopefully I think it's been long enough that we can jump back over and we'll take a look at the mold that we just made on our part here. So let me go ahead and share the other video, and we'll also share the GelSight mobile software. All right. All right, let me share the software here. And as I'm sharing the GelSight mobile software, if you want the video to be larger, you can go ahead and click the video thumbnail. And if you want the software screen share to be larger, you can pick the software. So it'll just change which one is the larger display for this. All right, so the first thing that I'll do, just to give a little bit of context in case you haven't seen the GelSight system before, is I'm just going to press my fingertip onto the surface so you can get an idea of the resolution there. So that will be what we're doing when we scan the replica and the surface of the part directly as well. So I'll go ahead and take the replica off of our surface here. This one has about a 6-minute cure time, so hopefully I've been talking for 6 minutes now. All right. And what we'll do is we will scan the defect on the replica first, and then we'll go through and we'll scan the defect directly on the part too. So I'm just going to come in here and we'll press the gel onto the surface like this, and we'll click the button to take the scan. And our 3D data is generating now. And we will open that up. And the first thing we'll do is look at it in 3D. So here's our 3D reconstruction of that surface. And if we increase the scaling, I'm going to change the angle a little bit, you can see we're looking at a raised feature. That's because when we're looking at a mold of something, a scratch is going to look like a positive feature. And a positive feature would look like a negative feature. So we'll come back here. And now that we've taken a look at that, what we can do in our software when we're scanning a replica is actually invert that data. Actually, I'll do that from the 3D view here, so it'll be a little bit more obvious. But we can see that raised groove here. And I'm going to click this button. This is going to tell me it's going to create a new height map. And it actually transforms the surface. So now we're looking at a scratch again. And this will look like what we're looking at on the surface of the part. So now I'll come in with our defect detection algorithm. We'll just draw a box around this area here, and we'll click Analyze. And there we get the characteristics of the defect on that replica. And then we'll come in and we will click PDF to generate the PDF report that will go with that. And so here's your reconstruction. And here's the defect that we looked at. And the profile through the deepest point, along with the outputs, including length, width, area, volume, and depth. So in this example, we scanned the replica directly. So as Thierry was talking about in the introduction, here, the workflow might be create this replica, then bring it to the metrology lab, and then wait for their availability to slice this and measure it on an optical comparator or something like that. But even when GelSight can't access that space, we can still scan the replica and cut down on that kind of transport time, basically. So I'll jump back into the capture mode now, and we'll take a look at what scanning this directly looks like. So I'm going to take our modulus system here with the 90-degree attachment, and I'm just going to come right in here. And we'll take a scan like that. And our 3D data is generating, and we'll open that up in just a second here. And we'll open the 3D so we can take a look at it. You can see the curvature of that part there. And now I'll come back in with defect detection again. We don't have to invert it. We're scanning the part directly. And we'll look at something like that. Actually, I'll rotate that a little more. Something like that. And we'll click Analyze. And then we're going to get the characteristics of that defect directly, as opposed to using the replica. And then we'll turn that into our PDF report as well. There we can see that. So from this, we're just kind of showing the way we can replace replica using modulus accessing directly, or how we can work with it as well. And we might see a little bit of variability depending if the replica material made it to the bottom of the defect there. We've seen a couple air bubbles, so this might take more than one try. Or maybe it's successful in the first try, but that's kind of another variable in that replica process. So I think with that, I'll pass it back to Thierry to talk about the value brought by GelSight and maybe some application examples where we've either replaced replica in a workflow or been used with replica in a workflow as well.
Yeah, thank you, Abby. Thank you very much for this very compelling demonstration. I think we have all seen that both for the measurement of a replica or the measurement directly of the defect, GelSight really brings an immediate readiness and the access to quantitative 3D data, which are extremely useful when you want to take decision, concerning, the retouch, the reworking of the part, or to scrap it, because sometimes the defect is such that the part which needs to be scrapped. And this is the type that information which is requested by our customers, and it's really in that sense that our customers sees a huge value in GelSight. We have few, as you mentioned, we have few examples of productivity gains observed by our customers. I have in mind two cases. The first one is the MRO shop of a large aircraft engine manufacturer. They went from 1.7 week per part for inspection using replica and confocal microscope to 2 days per part for inspection using GelSight. So they divided the time by 5. It's a factor of 5 between their previous workflows and procedures to the new way of analyzing things with GelSight. And their workflow typically went from 1 hour to get the putty, as exactly what did Abby, getting the putty, mixing the putty, installing it on the part, curing it, transferring it to the lab, to about a minute with GelSight modulus. And this is really, once again, a huge saving, for this company. The second example I have in mind is the manufacturer of landing gear, one of the leader of this world. To validate, the manufacturing process of a new landing gear, typically they need something between 200 and 300 molds, which is huge, and simply because the size of a landing gear, you cannot really transport it easily under the microscope or in the metrology lab. And with GelSight, they have been able to reduce by 80% the number of molds, for this type of process. Same thing. It's really a huge saving. And we have other example. I will not enter into detail, but it's just to show you that GelSight systems which have been developed in that purpose, to help customers to increase their productivity and reduce the non-quality cost. This is really something which is now on the production line, on the MRO shop, and we see that in most of the cases the return on investment of GelSight system is typically between few months and few weeks. In some extreme cases, just one single measurement justifies the investment of a GelSight system. And for us, there is no better indicator than the rapid adoption of Modulus, our brand new system. You have seen probably that GelSight since last September have sold more than 100 of these systems, which once again is a proof of the value brought by GelSight in this world. Yeah, now I want to thank you, Abby, and thank you all the people around this virtual table, for your attention, and we will be more than happy to answer to your questions.
Thank you, Thierry. So we'll have some time for questions now. I see there's a couple in the chat that we'll start talking about, but go ahead and use the chat to ask more questions throughout, and we'll go through that. The first question that I have in here that's going back and forth a little bit is how the global uncertainty is computed in the graphs that we showed for the M60 and M70. So this is part of a larger application note that we'll share, and it goes into the details of how that's calculated. We also have the spreadsheet that basically goes through the bias and standard deviation with the using K99 at 99% to go through and calculate the global uncertainty. So we can follow up after this and share the application notes with you directly. And then we have another question here that says, there is an issue when Rolls-Royce Germany tried this tool in 2024 to measure defects in fillet radii or smaller areas on the parts with bad access. Is there a method how to measure this with GelSight in this case? And is it replica in GelSight? So I think in 2024, we didn't have modulus. So I think that would be, a great starting point. It might be something that we can access now. So definitely we can follow up with that and try modulus out on these locations too. But in the event that we can't access it with modulus, or we don't have access to the modulus system, you can definitely try the replica method as well, especially defects on edges.
Yeah, we have partners in Germany already in contact with you, Rolls-Royce Germany, and I think they will be more than happy, to visit you and to do a demonstration with their modular system. They have, a system with a 90-degree probe, and you will not have, a better answer to your question than a demonstration on your part.
All right, we'll give just a couple more minutes here for any other questions that pop in. Who's our contact in Canada? So we can follow up with you afterward for who we can contact. And Thierry, if you want to add anything to that.
Yeah, we also have a partner located in Montreal area, so we'd be more than happy to exchange on this topic. And I think, Sergey, we already had a contact in the past, and so don't hesitate to contact me, and I will be more than happy to introduce you to our partner there.
All right, so we'll give it just another minute in case anybody is still typing. And I will also take this time to remind everyone that we will be recording this and it'll go online. So feel free to share it. I think we'll send an email out with the link tomorrow. All right, what about leading and trailing edges of airfoils? Can the GelSight create clear depth on transitioning surfaces? Thierry,
yeah, and we don't even need, a replica, except, when you have, the transition between the leading edge and the platform of the blade. These areas are typically sometimes difficult to reach. So in that case, you may need a replica, but along the profile of the blade, both for the trailing edge and leading edges, you can just use GelSight directly. Directly.
Yeah, I'll add to that. So even if, in the example today, we're making contact in the whole field of view, but if, we just have a blade edge coming onto the gel, that's totally fine. We'll just use different analysis tools for that.
Yeah, we have customers in the world of, helicopter engines, and that the blades in this type of products are pretty small, and they are using GelSight to measure, dents or, erosion on the leading edge of blades. And it's pretty well adapted to GelSight.
All right, we have one more question here. Oh, that Wally just answered, but I'll just go ahead and read it out loud so that everyone else can hear it as well. But when new technicians are hired, what would be the best method for training them to get up to speed? So we do have virtual or on-site training. So if you're interested in scheduling that, you can reach out to us and we can coordinate that. We do also have our user manual for reference, and then we do have some how-to videos on YouTube. So you can definitely check those out too, where we go through different analysis functions or calibration on there as well.
And regarding the software, does that require different software? No, all our functions, everything is included in a single software, which is compatible to the different probes you have in my background. So basically, for Max, Modulus, and mobile, there is only one software.
All right, so thank you everybody for the time today. We'll follow up after if any other questions pop in, but thank you for joining.
Thanks. Thank you very much.